Hi again, it's Ryan. On the bench today we have a couple of power supplies that look to be identical, except this one's obviously more yellowed, but they are not identical. One of these is for a 128, and one was supplied with the 1764 RAM expansion unit for the 64, because the 64's original power brick just simply wasn't delivering enough power to handle the extra memory. So let's take a look at the back of both of these. And again, on the bottom, they look identical. Right? The cases are identical, fuses are the same, and if we look carefully, we can even look at the voltages. On this one, output is 5 volts DC, 4.5 amps, 9 volts AC, 1 amp. For here, 5 volts DC, 4.3 amps, 9 volt AC, 1 amp. So absolutely the same power out. Now, if you look closely though, there is a giveaway. Here is a pin out for a round connector, and here's a pin out for a square connector. So this one is the 128 power supply. This one has the round connector for the 64. Now, the guy that I got this from said he had a RAM expander at one point in the past. He didn't know where it was at the moment, but this was the power supply that he had been using with his 64, which is good because it's probably why the 64 survived. But what we're going to do with this, we're going to test it and see if it's still putting out the right voltages, and then we're going to open it up, because on the 128 power supplies, I've rebuilt a couple of them here recently, and Commodore put, or Mitsumi I should say, since that's who made the board, put a bunch of glue around some of the components, and over time that glue has started to break down, and it's turning this kind of ugly brown color, and it's causing corrosion on a number of the components. So for instance, I had a 128 power supply that was so bad I had to replace a number of resistors and diodes and capacitors just because of the corrosion. Some of the leads had corroded completely through because of the glue. So when we get into this one, we're going to see what the glue looks like on this one, and if necessary, we'll remove it, replace any components that look like they're showing any signs of corrosion, and rebuild it. Okay, so the first thing we need to do is test this and find out if it's working and if we've got good voltages. I've got it plugged in. First thing we're going to test is the AC voltage. So we've got the little notch here, so this is up, and we've got pins 6 and 7 here at the top. So we're going to touch those two. We are looking for at least 9 volts, but because this isn't under load, and given my experience with the 128 units, I would actually expect that we're going to get something closer to 10. Okay, now it is kind of tricky to get a good reading with these probes because it's, you know, everything is round, but let's see what we can get here. 10.1. Alright, so that's perfectly fine, right? Even if it's a little above 9, it's not under load. 10.1, no problem there. Okay, so let's flip over and let's check the DC voltage. And for this, we've got the ground on pin 2, which is opposite the little notch, and then pin 5, which is just to the right of that. So we're looking for something around 5. Again, it's not under load, so we would expect something a little higher than 5. .19. All right, so that's good. We've got a good unit here. Now, I am still going to take this thing apart and check it on the inside because I am still concerned about the glue based on my previous experience with the 128 units. And I'm going to put some pictures up here in just a second and show you exactly why I am so concerned about the glue. So here's a shot of 2 of the boards out of 128 power supplies. I had 2 that I was working on at the same time. So I have a couple pictures of the units here side by side. You can see on the one on the left all that dark brown gunk around the base of the capacitors, around the base of the coil. You can see the corrosion on some of the resistors, on that little jumper there in front of the coil, on the base of the back leg of that tall copper jumper. It's just terrible. A couple of those diodes that are on the left side of the coil that you can't really see in this picture had to be replaced as well. If you look on the right, you can see that one's not quite as bad. There is still some corrosion that we can see in a couple of other pictures, but what you can see there is you can see a couple of the diodes that you can't really see on the picture on the left, and those were actually okay on that board, but you can see at least the position of them. And here's a shot of the underside of those 2 boards, and you can see there was also glue put on that resistor on the bottom left corner of the boards, and that had also deteriorated greatly, and both of those resistors had to be replaced as well. Here's a close-up of one of those resistors. Here's a shot of the better of the 2 boards. You can still tell where the glue is because you can see it's a tan against the white dots on the board. But you can really see the corrosion on the leg of that coil and also on the jumper there in front of it. And here's an overhead shot of that same board. You can clearly see the corrosion again on the leg of the coil, but you can also see damage there on the leg of the resistor in R10 and on R2 and on the diode that's there underneath that tall copper jumper to the upper right of the coil. You can also see on the bottom of the board there that yellow polypropylene film capacitor also had some damage on one of the legs, and that also had to be replaced. All right, now here's an overhead shot of the worst of the 2 boards, and you can see just how terrible this is. Basically, everything that glue touched had to be either completely replaced or removed and cleaned. So the coil and that tall copper jumper there, you can see the corrosion on the top leg of that jumper. I was able to save both of those, but they had to be removed carefully and thoroughly cleaned. But basically everything else had to be replaced. You can see just how badly corroded the jumper is there at below the coil. And there's another jumper there in the top right next to the tall electrolytic capacitor. That I think I was able to save that one after cleaning it. But the 2 resistors there on the right had to be replaced. That polypropylene film capacitor there on the right had to be replaced. On the left of the coil, you can see underneath that copper jumper, there's a diode there that was very badly corroded. The lead on the
upper side from this view was completely corroded through, and the body of the diode itself had suffered quite a bit of corrosion damage. There's another diode that you can't see that's hidden by the coil from this view that suffered quite a bit of damage and corrosion on the leads. There's two resistors up there that both had to be replaced. One of them you can't see from this angle, but you can see the leg of one of the upright resistors up there against the electrolytic capacitor in the upper right. You can see the corrosion on the bottom of the leg of that resistor. Basically everything in that corner of the board had to be either replaced or removed and thoroughly cleaned. You can see just how much damage that glue did. So it should be fairly obvious by now, I think, why I want to get into that C64 power supply and see if it suffers from the same kind of damage that these 128 supplies did.
Now the screws on these things are not simple Phillips head screws. They use actually a Torx design, which looks like a little six-pointed star. These used to be hard to come by, but nowadays they're actually quite easy to find. I'll give you another look at the head here. Let's flip it over. This top will just come right off. And here's the innards. So you've got your main board here. All the electronics are over here. Transformers here. You got power coming in here. So to get this out, it's actually very easy. It's not actually held in by anything. You just pop these up out of those channels, lift it straight up and out. Now it is connected to the bottom part of the case. Here and here it is soldered onto the fuse holder. So what I'm going to do first is I'm going to desolder this so I can get this out of the way, and it lets me get in there and take a better look at it. So let me do that real quick and I'll be right back. Okay, so I have removed the bottom case by desoldering the wires from the fuse holder. Now it is possible to remove the fuse holder. There is a plastic nut here. The fuse holder would just go in and this nut would screw on to hold it in place. But you can see here there is this blue trail. This is actually glue that was put there to hold that in place. So I don't mess with trying to take off this nut and removing the fuse holder, because that just seems like that's going to break if I try it. So it's just a lot easier just to desolder the wires. And these are the two, the orange and the brown. Doesn't really matter which of those connectors on the fuse holder you put them on. It doesn't matter. Okay, let's take a look at what we've got here. You can see the different wires here. So we know that red and brown go to the fuse holder. The red and the black carry the 9-volt AC. And then you've got the white here, you've got the ground. Okay, so that's going to get your DC voltage. Now, if we look in here, this actually looks to be in pretty good shape. On the 128 power supplies, there's a bunch of glue over in this area. and you can still see a little bit. There's a little bit in there. You can see it's kind of discolored, a little more obvious maybe here between the capacitors. But there doesn't look to be any corrosion, so I'm not going to mess with any of that. I'm not going to mess with trying to take that off. There's a resistor here on the bottom, right here. You can see some glue around that. On the 128 power supplies that I've looked at, that's also been very, very corroded. This doesn't really look to be in too bad a shape, so I think I'll leave that be as well. But since I've got this open, I think what I'll do is I'll take this off and replace these capacitors while I've got it here. So, first step, got a couple of screws here. This screw needs to at least be loosened. Depends on how it's actually attached there. And then it looks like there's some glue or something holding these two components on. So we'll have to see what that looks like when we get it. We get those screws removed. And these are, luckily, just standard Phillips head screws. Now the only thing that's holding this on right now is this connection here. Move this. Yeah, let's open this up enough where I can take it off or slide it all the way around. There we go. Okay, so this one looks like it's come completely up from the thermal compound that was connecting it, or was holding it against the shield. This one looks like it's still kind of stuck to it. There we go. Okay, so that one's up. Pull this right off. We'll give this a good cleaning and put some new thermal paste on there before we reattach everything. Alright, so we've got 3 big capacitors here. Got a little one here, a little one under here. And we should be able to do all of those without removing any other components. Now, I've mentioned in a couple of my other videos that when I'm desoldering components, I like to identify them on the back of the board and mark them with a red Sharpie so that when I'm desoldering, I can be completely confident that I'm desoldering the right thing. So if you can see, I've marked a capacitor here with these two, here with these two, here with these two, these two, these two. Okay. So those are all my capacitor leads under here that I need to desolder. Alright, so I have desoldered some of the capacitors. This one's already out. I've desoldered these three big ones, but they're not going to come out very easily because they still have glue around the base connecting them, that's holding them to the board. These two actually have some glue running up the side holding them to each other. So if we look at this one is completely desoldered underneath. You can see it moves quite freely, but it's being held in still by the glue here at its base. So I don't want to be rough on this board. So what I'm going to do is I'm going to very carefully stick a toothpick in there, and I'm going to see if I can't just get enough of that broken loose with the toothpick to get that out. Okay, because I don't want to use anything too that might scratch the board too much. On the top part of the board, it doesn't really make that much difference, but if I can avoid it, I will. And this glue does tend to get kind of flexible. There we go. You can see in this case the toothpick was sufficient, even though it did give its life in the pursuit. But you can see in there where the glue residue remains. You have to be really careful now getting out these other two since they're glued to each other. But because they're glued to each other, the first thing we can do is separate them. And I'm going to do that with an X-Acto knife. Just very carefully run this up between the two, putting a little bit of pressure here to pull them apart. Yep. Okay, so they're free at the top. Still have a lot of glue holding them on at the bottom. Okay, so I've used an X-Acto, and I've been able to separate the two capacitors here from each other. But now there is still some glue at the base, and I don't want to be too rough on this. If I can pull straight up, I will. Yeah, that glue is holding it on there pretty tight. So we're going to have to scrape that a bit. And I don't think this time a toothpick is going to cut it. So I'm going to use a little screwdriver. Okay. And all I really did there was try to scrape the glue away from the bottom of the capacitor. And now that this one is free of the other one, looks like it's going to come out pretty easily too. But the glue on this one actually is in remarkably good shape. So I've got one more capacitor back here to remove, I'll scrape this off a little bit as gently as I can, and then we'll start with the new capacitors. And we're back, and the new capacitors are in. So the next thing we need to do is put some more thermal compound on these guys and put the shield back on. Now all I have left to do is to reattach the fuse holder, put the case back together. I'm going to go ahead and do that off camera because it's not really that exciting to watch. Alright, so we've got it all back together again. Let's just test it one more time and make sure that everything is still working, that we didn't screw anything up. So I'm going to start with the AC voltage again, and it's pins 6 and 7. .1. Okay, that's good. Now let's check the DC voltage, and again we're looking for around 5 volts, probably be a bit above. .19. Very good. Okay, so we have a working unit. The voltages are all good. It's got new caps. Basically all that's left to do is clean this thing up. Thanks for watching.